Okay, everything is working. So today, as I wrote you on Telegram yesterday, we are going to follow the schedule, and we are going to talk about the useEffect API in React. Okay, this is the schedule for this week. So tomorrow there will be a lab about what we are going to explain today. And then there will be another lab next week, as usual. Okay, on Tuesday, sorry, and they will deal basically with this topic that we're going to introduce today, which is rather big and very important because it allows us to communicate with the server. Finally, okay, eventually, I would say. Okay, so. There's the solution. I didn't link it from here, but I mean the solution is published. Okay. Also for last week's lab. Sorry. Okay. So let's go talking about this API. Actually, it's a much larger discussion. It is about the life cycle of React components. Okay. So that's why it's called life cycle. So actually, we only saw components when we are updating the components until now. So we wrote a function in components that basically returns the JSX, that is the one that needs to be rendered when React needs to show something for that component. Okay, but actually. Each component has a life cycle. It means that it starts to exist at a certain point in time. That is what is called mounting. Okay, the React mounts the component actually in a certain place in the element tree. Then this component exists and is updated every time React deems it's appropriate. So every time a props or a state changes, okay, that involves the component. And then at a certain point, it may be unmounted. It means that it disappears from the element tree. Okay, and in this case, it's simply destroyed. Okay, so all the state belonging to the component is lost. Okay, so the point is that we need to understand what's happening to the component because we might need to customize what happens at different moments in the evolution of the component. Think about your main page. You load the application, the main page is mounted, okay, and you want to populate it with some data, okay, coming from the server actually. And so at that time, so at the mounting instant, you would like to attach some code to that moment so that you can start loading data from the server and then use it in your application. This is just an example, the most common example. Okay, so just keep in mind that this is the life cycle of each component. It starts from being mounted in the tree, then it's updated many times depending on what happens in the application, and then at a certain point it's just unmounted, so it disappears. Okay. It might never disappear in the sense that, I mean, if we change page in the browser, everything disappears, okay? But depending on how you structured your application, for instance, now you know the router, you change the page, some components are not rendered anymore, they're simply unmounted, okay? Okay, so this is a picture that basically tries to, let's say, explain this with the drawing. There's the render phase in React, that is what we saw until now. So every time React needs to show something, it goes to the component, executes the code of the component, and takes the return value, which is the JSX, and shows something. Okay. And there is this commit phase, okay, where we will attach code today. That is basically what happens after React has run the component. So it got the JSX, and there we can attach some code. Sorry. Here with this useEffect to run what they are actually called side effects, so things that are not do not belong to the render of the component, additional code that you would like to run at a different time instant. Okay, Okay. So actually a side effect is just anything that we do that is not related with the actual output values of the function that implements a component. Okay. So anything that affects something outside the scope of the function component being executed. That is the typical example, the one in bold, data fetching. Okay, we go to the server and we ask to perform some operations on the server. Typically loading data, but can be also storing data, updating data, and so on. Okay, and anything that is not related with rendering, so log recording, setting a subscription, and so on, managing timeouts and stuff like that. Okay, but this will be more clear later on after we talked about and we made some examples about these side effects. Okay. So component rendering and side effect logic are independent. Okay, even though they might be, it looks like they belong to the same place because we are actually writing them inside the component, but actually not in the return stuff. Okay, in another place we are calling this useEffect hook, giving it some code to execute, but actually the code is independent of the render phase of the component. Okay, and actually you shouldn't perform side effect actions inside directly the body in the body of the component. So in the code that you write in the body of the function that implements the component. Okay, so let's see some examples. Yeah, before that, I mean, there's a picture, the previous picture. So in this render phase, we should not run any side effects. So we cannot just write fetch something. Okay, why? Because actually we never know when the code is going to be executed because it's controlled by React and not by us. Okay, so it can be executed multiple times depending on what React needs to do. Okay, for the rendering. While in this second phase, which is actually called the commit phase, when the updates are committed inside the actual DOM of the browser, we can run these side effects. But actually, we have no place where we can write this code, right? So at the moment, there's no place, and now I will give you a solution. I mean, what React wants us to do to write this code. And so actually, we need to use this hook and call it, surprise, with a function, okay? Passing a function that has some code that we would like to execute, okay? As usual in JavaScript. So let's see this useEffect hook, which is probably the most complex hook which React allows us to use, okay? We are not seeing so many hooks, but I mean, this is really important. And of course, you will have to use it for the exam, and I will check how it's used at the exam for sure. Okay, because it's so, I mean, it's the most important thing you need to write inside your application after designing the structure of the components and how they appear and so on. Okay, because this allows you to communicate with the server and so on. Okay. So let's take a very simple component, okay? Function greet, I mean, just a name of component, okay? Returns a message. This message is taken from props name plus hello, okay? Calculates the output, returns the JSX. Okay, that's fine. That's the usual stuff that we have seen until now. Let's say we want to have a side effect, like in this case, it's very simple. It's just a console log, okay? Something that it doesn't affect the output of the component. It can be something more complex, as I told you, load data from the server and so on, okay? Where do you put the code? Well, actually, you confine it, so you restrict the code to be inside the useEffect hook. Actually, the first parameter that you pass is a function that will be executed at a certain point in time by React, okay? And of course, you can use anything that is allowed to be used in JavaScript, like this message, okay? You know, when you write something like this, you create a closure of a message, the variable, and so the function that is passed to the useEffect will remember the value of message, and it will be able to access the message value even later on, even when the function is not being executed anymore. Okay, that's the user stuff. And depending on the second parameter, this function will be executed once, many times, every time, and so on. And we will discuss this in a minute. What you shouldn't do is what you see on the left. Okay, so console log here directly in the code of the component, because this is executed every time the component is being rendered. So every time React decides to render the component, and we don't want to have a situation like this, because here it's very simple. I mean, the console log has no real does not really create problems for React. But if you let's say subscribe to some communication system, you log something, you want to load data from the server, store data on the server, and so on, you don't know how many times this function will be executed. Okay? And so, of course, this will not work properly for your application. Okay, so how to use the useEffect? This is the way in which we need to call the useEffect. First parameter is a callback, so it's a function to be executed later on by React. And then there is an array that contains a list of dependencies. Okay, that basically decides when to execute the callback. Okay, so this is actually optional, but I would say it's almost mandatory, because without it, basically every time the component is rendered, the callback is called. So I mean, it's not really useful for us. So in this optional array of dependencies, we will store the values that tell us that in case they change, React has to call the callback again. Okay, and if the array is empty, as we will see in a minute, this callback will be called only when the component is mounted. So only at the beginning, when the component starts to exist. Okay, this is a very dense API as it's written here. I mean, because depending on the second parameter, you can achieve many different behaviors, and we will see examples today. Okay, so the dependency array, if not provided, the side effect, so the callback runs after every rendering. Okay, not it runs after the rendering. Okay, not during the rendering. So it's not the same as writing the code in the actually the body of the component. An empty array, the side effect runs once, only one time after the initial rendering. And if there is a list of values, typically props and or states, these values will decide when the callback will be called. So the code associated in the callback through the useEffect API will run every time once when any dependency value changes, and in addition also once after the initial rendering, so it means after mounting the component. Okay, so if you have something as a second parameter, it always runs after the component is mounted, and then it's empty just that time. If there is a list of values, when one or more of these values change, it will run again. Okay, so this is just an example how to use it, but I mean very simple. Just you don't have a second parameter. Okay, you have an empty array, open and close the square bracket, or you have a list of values. Okay, this is very generic. I mean, it's not supposed to be an example that works for some purpose. It's just for showing what you can put here. Okay. Okay, so let's see some examples, because I'm sure, I mean, it's a bit difficult to understand these things just talking in theory. Okay. I have it in the code. I already committed it on the GitHub yesterday, so we can try to use this code. But first of all, let's read the code. So there's a component, function count, we take some props as usual. Okay. And this is called in this way. It means it's rendered somewhere else in the application as a component with some attributes. So num equal to num, that becomes a prop because it's an attribute here, of course. And there inside there's a button, on click, set num, etc. I don't really care. There's probably a state, okay, because I set num, and so probably num is a state. But it's passed as a prop here, okay. And so let's assume it just prints the prop, okay. I mean prints, it returns the prop. So actually this is JSX. It shows it in the page, okay. Let's say we have a useEffect that has a callback, which is just written here in line just to try something. Okay, so console log, my number is props.num. That's fine. Empty array, it just run once when the component is mounted. Okay, and instead you put a value here in the dependency array. Every time the value changes, this useEffect is run. And in addition, as we said, it is run at component mount time. So the first time the component is rendered. Okay. So what you get is what you see here below. Okay. First time the count is rendered, my static number is, and my dynamic number is. And then the first side effect is not run anymore because you have an empty array. Okay. And the other times that the num changes, okay, every time the num changes from the previous value, so React with the useEffect remembers the previous value, you just run the code, and so you print the my dynamic number is, and so on. Okay, so every time basically you change the state, it becomes a prop here, and the prop drives this useEffect and says to the useEffect to run the code. After the render, okay, you print the console log my dynamic number is with the new value. Okay, and you see also the first value because, as we said, it is run also at the beginning after the first rendering. Okay, let's just try the example. Okay, so I have this lifecycle slide examples already published here with the examples. Okay, they are on the Git. Okay, src. So that's up. This is this count, grid, and so on. Other example we will see in a minute. Okay, so how do you run them? Well, in the usual way. I already did npm install and npm run dev. It's a React application. So it's basically a page in which I put everything, okay, all the components that we're going to see in the examples of the slides, just for convenience. Okay. So this is what we were seeing before. So you see there's this div with the value, the button, and so on. We see in the code client app, okay, it's account num, on click set num, and of course we have a state. We start from 3, just as an example. Okay, count is implemented here exactly as it was shown in the slide. Okay, so how does it work? I mean, it's very simple. Where does it print? Well, of course, in the console. Console log prints in the console. Okay. Let's forget for a moment all the stuff, all the rest of the stuff that is printed. Okay. I reload the application because the component now is already mounted. Okay. So I want to show you what happens at mount time before I do anything, before I press the plus. So just forget about the rest. Okay. Oops. You see that we have this console log. Okay, my static number is 3, my dynamic number is 3. Okay, that's what we expected here in the first two lines. Sorry, first line, second line. Okay, this is what happens at mount time for both of the useEffect. Actually, for any useEffect, because any useEffect runs the callback at mount time, regardless of the second parameter. Okay. Okay. Why do you see the message 2 times? Well, this is just a react debug mode. Okay, you remember that we saw in index, no, in main. Well, the strict mode. Okay, the strict mode basically tells React to do additional checks and so on. It's fine to have it. It doesn't create any problem to your application. If it creates problem, it means you have something wrong in the code of your application, because it shouldn't create problems. Okay, when you run stuff, when the component is mounted, you shouldn't do operations which are not idempotent. Okay, so you can redo the operation, even fetching data from the server and so on. Just fetching data is fine. Okay, but I just wanted to tell you why we see twice, okay, the output. That's just the reason. And don't touch this code. Okay, you just need to know that when the component is mounted, actually React in this strict mode, which is a sort of debug mode, mounts the component twice and check if what happens is actually the same. In case it's not the same, it gives you a warning. Okay, just to make sure you didn't do anything wrong. Okay, okay, good. Okay, these errors are related to something that we are going to see later. Okay, okay, so something which is in another place. Okay, in the page. So let's try to press the button, the plus. Right? This becomes 4, but this is stuff that we already know. It's a state. We do +1. Okay, you remember the code. We have the code here in up. On click set num I arrow I +1. Actually, the state depends on the previous state, so don't forget, use a callback, not the actual value, not I +1, but I arrow I +1. Okay, actually not num +1. Okay, so let's try it. Click, it's fine. Okay, this is the output of the second run of the callback that was written here. Okay, so inside the second useEffect that has a dependency on props num. Props num has changed, now it's 4, and so React after the render decided to run the useEffect. Okay, which actually prints something in the console just to make things simpler. Okay, and so on. If you press it again, you get 5, and so on. Okay? So this is just to show when the callback is run by the useEffect. Okay, good. Yes, there's a question.
But if I remove the dependencies from the second useEffect, I'm seeing results.
You move it where? Where do you want?
Move props num and also the square bracket.
Oh, okay, yes. Yes, actually, yes. I mean, in this very simple case, yes. Okay? So basically, since you create, I mean, when you change the state, you force a re-render, yes. Actually, that's the same. Okay? It was just to show you. Okay. Because, I mean, this condition is not very common because it's more or less like writing the code directly inside the body of the component, which is not actually what we typically want to do. Maybe we want to do it for logging purposes, but at that time, I mean, the border between debugging and logging is a bit blurry. Okay, and so actually, I mean, it's better to maintain the purity of the component, so use the useEffect, so you run it after the render, but I mean, in practical terms, that's a little difference. Okay? Okay, so thank you for the question. And so this is what we have just seen. Actually, this is the timeline. Try to read it very carefully and make sure you understand what's happening. So the component count, with this name, count is created with the number equal to 3 passed as a prop. It is mounted. So the function count is called. useEffect are registered. So it means they are not executed immediately. Okay? Because remember, the useEffect is just a function that you call. function by React that you call. You pass a callback, and this callback will be executed later, okay? As any callback. It's not immediately executed, okay? If the function does not want to execute it immediately, like the useEffect. So useEffect basically registers the callback and when it should run. So it put it inside the React library in some place. It remembers it. Then you have the return. So the JSX is returned with the number equal to 3. It's fine. And so React will render this stuff. It will enter the commit phase. It will transfer this div, etc. to the DOM. Actually, you see it in the browser. And then it goes to check if some useEffect has been registered. And in case, it runs the callbacks. So the component was just mounted. So run the first useEffect. So this code, the callback that has been registered before. Component just mounted, run the second useEffect. Basically run any useEffect that has been put inside the code of the component. And then nothing happens until the user does something. You need to wait for some events, right? This is how web pages work, right? And then the user click, that is the only thing that can make this count re-render. So the app updates the state value. So num becomes 4. Num is passed as a prop to this component. So React understands that's a difference in the props for this component. So it runs the code of count again. So function count is called for re-rendering. Actually, the useEffects are called again. Okay, so they register the same callback. And the JSX is returned with the values 4. And now React knows it's not the mount time because count has already been called once. So the first useEffect, even if it's re-registered, is not run because it has no dependency. It has an empty dependency list. And JSX is, the props number has changed. Okay, the previous value was 3, the current value is 4. So React remembers the previous value. It see that it's different from the current value, and so the code of the second useEffect is run, and so we get this console log with 4 as a value. Okay, and again for the next the next times. Okay, so this is the actual timeline of all the operation that happens inside React. Okay, so we had actually a prop as a dependency of the useEffect, which is fine. I mean, we can have any value as a dependency in the useEffect. Actually, it was a prop coming from a state, very common condition. Sometimes you just want to have directly a state as a dependency of the useEffect. So everything is fine. You can have any value, okay, as a dependency of the useEffect. Just keep in mind that if the value doesn't change, the callback of the useEffect will not be run, okay? Because the useEffect is supposed to call the callback only when one of the values in the list of dependencies change, okay? But this mechanism is useful because you have some code that might be asynchronous code that you might want to run after the component is rendered. And so if you put as a dependency a state, and at a certain time you need to run this code, you just change the value of this state. Okay? Can be a Boolean value, can be a counter, can be anything you need. Okay? Okay, so this is one of the most common patterns in programming with React. Okay, let's have a look at an example. That's another example, and we have a demo for this as well. Okay, quick gate. So it's a gate. I mean, virtual gate. It's just actually some text that says open or close, I think. Okay, and there is a state. const open set open user state false. Okay, so it's a Boolean state. It's a variable that says if the gate is open or not. Okay. There is a return value here. So the JSX that just says if it's open, you write go. Otherwise, you write stop. Okay, nothing really special. You see here stop. Okay, it's closed. In case it's open, it's go. Okay, we didn't have a nice animation, so just a text. Okay, and then you have the possibility to click. Actually, on this text, you can click on anything, right? In web application, you don't really need a button. I mean, anything can have a non-click handle associated with it. So openMe, it's a function that just does one thing. It sets a state. Set open true. Okay? So it opens the gate. And then we should have another button to close it, but that's not what we want. Okay? We would like to have this gate closed automatically after a certain amount of time. Okay? So how do we implement something like this? I mean, without the useEffect, there's actually no way of doing that, because what do you do? I mean, you should write something like set timeout here. Yeah, it's fine. I mean, no, actually, you can do it with the without the useEffect. I mean, more complex example cannot be done. But I mean, let's assume at the moment. I mean. That I mean, we are in a more complex situation where I mean, it's not so immediate that after you set the state, you want to set the timeout. Maybe there are other more complex situations, like you need to wait for some data coming from outside sources and so on before closing it. Okay, it's fine. We need to put this. We need to update the state, so close this gate in response to an asynchronous event. And the simplest asynchronous event we can implement in JavaScript is basically a timeout. Okay? Later on, it will be arrival of the data from the server. Okay? And so let's just write the useEffect that says when the value of open changes, so we set it to true instead of false, and actually also false instead of true. This is for later. Just run this code. Set timeout, a callback that takes 0 parameters and just says just do set open false after a certain amount of time, 500 milliseconds, half a second. Okay? Okay, good. So what happens here? Well, component quickGate is created, mounted, of course. Function quickGate is called, and the user state creates a state with the default value false. And so useEffect is registered, not executed. Always remember that, you know, when you see the useEffect, just a callback that is passed to React for later execution. JSX is returned with the stop value because open is false, so you get the stop. Component is just mounted, so you run the useEffect. Okay? Actually, the useEffect, the callback of the useEffect is run. Because we say that's the definition of how it works, the useEffect. So set timeout, set open false after 500 milliseconds. Okay? Regardless of the value of open. So the timeout expires, the set open is executed, and the state open becomes false. So actually we say to React, well, just set the state as false value. It was already false, so nothing else happens, because React re-render the component only if the state or props change. The state has not changed, has just been set, but at the same value. So there's no change, no re-render. Okay? So that's why you see the 3 dots. Nothing happens. Nothing happens until the user clicks on the text, so on the gate, and the openMe callback is called. It does set open true. Okay. So actually now the state has been changed. So React re-renders the component. Okay. So component re-renders, The JSX is returned with the go, so something is changed in the appearance of the component. And the useEffect finds that open has changed because it remembers the previous value. Previous value was false, now it's true. So it runs a set timeout, okay? So it schedules this callback, the set open false, for execution after 500 milliseconds. After 500 milliseconds, without doing anything else, the set open is executed, so the state becomes false. This triggers a re-render of React because a state has changed, okay? So the component re-renders with a stop because the open now is false. And then the useEffect find the open changed again because it went from true to false. And it happens the same that happened at mount time. So after 500 milliseconds, we have a set open false, okay? And it basically has no effect, okay? So just to tell you that sometimes you run the callback inside the useEffect and simply it has no effect because it sets a state to the same value that was already set, okay? You can also change the code. You can write if open is true, then, okay, that's another option, okay? But the callback is always called, okay? What you execute is up to you, but the callback is always called by React, regardless of what you have written inside. It might simply not have any effect. Just try the example, okay? So stop, I click, you see it becomes go, and then it becomes stop again. Nothing is printed, there's no console log, okay? Just click, okay? That's a way, for instance, to implement behaviors that depends on the fact that some time has passed in your application, okay? That's a possibility. For instance, you want to have the time that updates automatically inside your page, okay? You just define a useEffect. At mount time, set interval or set timeout. But with the set timeout, you need a state, or with the set interval, it's fine. Okay. Okay. So just try to, later on, go through this timeline and make sure you understand every step. Okay. Okay. Just a few more words about the useEffect. Make sure that the array of the dependency includes all values from the component scope, such as prop and state, that change over time that are used by the effect. Okay? Because if you don't include them in the list, it means that you want to run the code that takes some values and you expect to use these values. This value have changed, but the useEffect will not run your callback, okay? Because you didn't list them. Because it's up to you to list them all the values that you need in your code, okay? The useEffect doesn't read the code. Just execute the code. It's up to you to make sure that everything that is used inside the useEffect, the code of the callback in the useEffect is listed as a dependency, okay? Otherwise, well, you simply risk your code doesn't work as you expect. You use a previous value. Okay. Just be careful that inside the callback of the useEffect, at a certain point, you need to stop changing values that belong to the dependency array. Otherwise, there's the risk of creating an infinite loop. Okay, as you know, it might happen in many other cases, okay? And this behavior is not it's not good for the exam, okay? So basically, if you have this callback that is called again and again and again, you keep the browser busy because it needs to run JavaScript code, and typically it's a bug because, either you need to compute something, and so it's fine, but at a certain point you need to finish computing something, because the web application waits for user input. Once he has the data from the server and the user is doing nothing, I mean, it shouldn't be doing anything, okay? If you want to make sure there's no infinite loop, just put a console log inside the callback, okay, just for debugging. If you see this console log going, printing stuff all the time in the console browser, it means there's an infinite loop, okay? I think the React at a certain point should give you a warning as well. In any case, I mean, this is something to avoid, but you know, when you develop things and you have a long list of dependencies, and you start changing code here and there and so on, sometimes you might risk incurring in this condition. Just be aware of the fact that it might happen. I mean, React does nothing to actually prevent it, because it doesn't know if it's actually a loop or not, okay? Because it might be that after a certain time, after you change the you know, some values, you stop changing values, and so the code is executed, everything has been executed, and you just wait for the next event. Okay? Okay, let's see something with the fetch. So the last step. So we can play with the server. Okay, which is the final objective of these lectures. So the useEffect can perform data fetching. So a side effect which is actually taking values from something which is outside the structure of the React components. And what do we do when we get some value inside the callback? Well, actually, this value inside the callback needs to be put somewhere to be rendered, okay? And in the React ecosystem, actually, the only place where you can put the stuff to be rendered that might change dynamically is a state, okay? So inside the useEffect, as we did before, with the state of the gate, open or closed, we can also put data. You already did it in the lab, right? You had the film list. You need to change what is to be shown because of the filters of the delete and add and so on. Well, actually, the filter, if you implemented it correctly, as we expected, it doesn't require a different state. But actually, deletion, addition, and so on requires a state because you need to change the list of films. Right? And so here, when you get the information from the server, you just set the state. And if the state is used in the return statement, so for the JSX, it will change what is shown. Okay? And so what you load asynchronously, you will be able to show it in the interface. Okay? So let's have a look at this code. Okay, so we have a component, fetch employees by query, that takes a prop query, okay, which is made as a value in the dependency list of the useEffect. So basically we are saying here, every time the query, the value of query changes, you need to run the callback inside the useEffect. Okay, so this async function fetch employee, await, fetch, etc. And it does set employees. So at the end, after the await, it will set the value returned by the response, okay, of the fetch. And the rest happens automatically because when you set the state is changed, and the changed state will trigger a React re-render. Okay. So basically, the useEffect is a way to be able to run something in a controlled way, in particular the fetch from the server of some data, setting the data in the state when you have it, and let the React do the rest. Okay? And we have a way here with the dependency list to say when you should run the code. Otherwise, without the useEffect, you only have the option to write something inside the component, but then it's run every time the component is rendered. It is not what you might want to have. Okay? Like typically, you load the data from the server only at the beginning, and then when you think it's appropriate, so you changed something, you added something, you deleted something, and so on. Not every time you render the component. Okay? It costs in terms of resources, it is very costly to go to the server, ask for data, because the server has to do some processing, return data, you use the network and so on, so you cannot just keep asking data from the server, okay? You ask the data initially at the beginning from the server to get some data, to show the initial values that you care about, and then when you do some modification to the data, you will communicate with the server and you will update the data according to the logic of your application. Okay? So in principle, it's very simple. You see that you write a fetch as we already did. We talked about the fetch. Remember, the fetch returns a promise. Okay? So you need to, in some way, wait for the result of the fetch, either with the await or with the .then. Okay? There's no preferred way. Here it's, await is a bit easier to read, but any way is fine. And then you will see we will isolate this code in another file, so we can do some checks around the fetch, just in case there are some errors and so on. So, but this is just a way of making things more practical. Okay. In principle, you can run, you can actually run a callback that at a certain point it stops. Okay. This is JavaScript. There's nothing that prevents you to write something that at a certain point stops, like with the await. And at a certain point, it resumes because the promise is solved, and it continues the execution. And at a certain point, it just calls the set of the state. So this will connect again with React and will trigger the re-render of React. Okay? So everything in the application is updated according to the value of that you got from the fetch. Okay? Okay, we don't have an example for that. We will have an example, a similar example. Okay? But just before going to a simpler example, that involves a server, a very simple server. Actually, just a note, the callback argument of the useEffect cannot be an async function. Okay, so you cannot just define an async function and pass it directly. But the nice thing is, there's a very simple workaround. It means that you define a normal function, not async with the brackets, but normal brackets. And then you define a function inside and you call it. Okay, just a trick, but I have to tell you. Okay? Because, I don't know, there's probably some restriction in the implementation of the useEffect in React. Okay? I'm not really sure why we should expect the code. So let's come to the example now. So we have this condition. We have a browser. We would like to run this very simple application. I'm going to show it to you in a minute. So there's a text box where you can type, and there is a server that takes this text. So we send the server this text, and it returns it back in a flipped form. Okay, what's this flipped form? We don't really care. It's just a trick like, rest is the same. A comma becomes an accent, and the D becomes a P, and so on. Okay, that's a library that does it for us. It's just something that basically does some processing on the server side, just to show you something which is not really, just do +1. Okay, something that's too simple. Okay, and actually this is the structure. We have a browser. We have an initial request, so when we load the page, localhost 5173, that is the React development server, we load the content of the page, including the HTML and the JavaScript. And then at this point, we need to insert this second server, which is the API server. You remember that we left the API server in a corner for a few weeks. Okay, we already have the API server. Now we will resume it and we will attach it to our application. But the point is that it runs on a different URL, so localhost, a different port in this case. Okay, so we have two different servers, which in general is not a problem, but there are some issues to make all this stuff work. I mean, here today I will just tell you how to make it work, and next lecture we will talk in more depth about why there is this need and what are the security implications and so on. Okay, so for today you just need to trust me. Okay, so this is the situation we have. The initial web server, that is the one that we run with the npm run dev, and then we have to run a second server. Of course, on a different port, because we are just using localhost. We don't want to have a second server somewhere in the internet, in the cloud, wherever. Okay, otherwise could be simply a different URL without the port. And this is the API server. So it responds to our fetch request, and it will give back some content. Okay, so this is the code. So text flipper, that's a different component. Text props, I don't think we use props here. No, we have two states. One is the text text, which is initially empty, because actually we have an input type text. Actually, this is a controlled form. So the first one is the state of a controlled form. Okay, you remember the forms, hopefully, and for each field in the form, for each thing that you can change, you have a state. Okay, that's the way in which we implemented the forms in React. And then there's a second state that will contain the answer coming back from the server. Okay, so the flipped text is called flipped. Set flipped, and then initially it's empty, it's fine. And so we have an input type text, value text. That's the way in which we write a controlled form. On change, handle change, there's a function here that basically does only one thing: set text, even target value. So this is what we write for the controlled form, nothing new. The new thing is what we write here to do the loading. Okay, you remember the previous example, we had the query as a dependency. Here we have the text as a dependency. Okay, so every time text changes, and text is what is contained in the controlled form, we run this code. It's actually, we want to run it as an async function, so we define an async function, and then we call it. Okay, so fetch flipped async, a way to fetch /flip with some text, which is actually the value of the controlled form. We await for the response, we convert it into JSON, and we take the value from the JSON. Okay, because we say that from the beginning of this course we're going to use the JSON to exchange information from the server, the client to the server, and vice versa. Okay, of course you can just exchange text in this very simple example, but just to practice with for the rest of the course, I mean, we just start exchanging the JSON. So very simple object that has a field which is named text, and then we run it. Okay. And last operation of the function is to set the status, the state of the component flipped, which is of course used here in the JSX to be shown to the user. Okay, so this flipped text below. Okay, on the server side, what do we have? Very simple stuff, no database. Okay, so that's the simplest example that we have. No database, because we just use a library that takes an input as input the string, and it flips it and gives it back to us. So we just have a route .get /flip request response query text, because we pass it after the question mark. That's a possibility. Okay, actually that's the only possibility if we use a get method, so it's fine. And otherwise we should define / something, but then I mean, it becomes difficult because we don't allow the slash character in the rest of the text. So, I mean, well, just try not to focus too much on these things, which are just details. And then we just flip, and flip comes from this library, so it's a library function. And then we send a response JSON with an object. You see the curly bracket text with field text, that is the one we access here. Text with the content, flipped text, okay? And then we start the server. Let's just try this example and see if it works. Okay, the code is published, so it's this one. Okay, let's clean up stuff. Actually, to run this example, you see that now nothing works. You need to have a server running as well. Okay, so I just started the client. You see, this is the client. I need to open a second terminal in, yeah, just not to mess with the directories. I think server. And there is an index.js, so node or nodemon, up to you, index.js. Okay, we're not going to change the server code, so node is enough for now. So, let me reload the page. Okay, so that's all the stuff that we have seen before. Okay, and then A, B, C, D. Okay, you get the response from the server. How do you see it's a response from the server? There is a request and response going and coming back from the server. Well, you remember there's a network tab. Okay, so you see the requests here. Hope they are large enough. So flip text, text is empty, still empty. A, AB, ABC, ABCD, etc. Okay, just clean up. Let me clean up everything. Okay, so E, N, R, I, C, O. So you see, every time I change on the on change of the form, we change the value of the controlled form, which is in the list of dependencies here. Okay, text is in the list of dependencies of the useEffect. So the callback of the useEffect is run with what? With the value of text. And then we wait for the response. We get the response and we set. That's a waiting, additional waiting here. It doesn't matter. We set flipped response body text. Okay. So there is a second example which is a bit more complex, just in a few slides. Okay. And the rest happens automatically, as usual, with React. Flipped is a state. If it changes, React re-renders. Okay? Re-renders, it rerun the useEffect. Text is not changed because it's flipped that is changed, not text. So the callback is not run again. Okay? A second time with the same value. Okay, good. So let me show it. Just one thing in the beginning. Let's clean up. Reload. Okay? You see, again, there are two calls to the server. That's exactly the same reason as before, because the useEffect callback runs at mount time. And because of this React strict mode, it runs twice. Okay? But it's typically not a problem, because typically in this useEffects, we only do operation which doesn't change the state of the server, like those ones, the get. Okay, the get doesn't change the status of the server. You can have a different response, that's true, but we cannot do anything about it. But it doesn't change the state on the server. So it's not like adding something and so you add something twice. Okay, if you do it there, there's probably something wrong in the logic of the application. And ask us in the breaks, during the labs, and so on, because we need to check what's wrong in your way of thinking, because it shouldn't happen. Okay. Also, if I see something like this at the exam, I will for sure ask you why you wanted to do this thing at mount time. Okay, because actually there's no reason to do that. Okay, so. So we saw this example working, right? Okay. Just a note of using the two servers. There are security limitations in what the browser can do when you contact more than one server at a time, because you load the page from one server and you want to interact with the second server. We are going to discuss these things next lecture, so I think on Thursday. Just for today, just trust me. I mean, we need to just allow these things to happen, and this is a configuration on the server side. I know it's a bit weird, but we will discuss it much more on Thursday. We just need to insert a couple of lines, and Thursday we will understand what they do and so on and why. So just we say that the server use a middleware which is called the CORS, that stands for cross-origin resource sharing. We will see what an origin is and so on. But I mean, for now, just trust me, you need to have it, otherwise it doesn't work. Okay? So basically, the browser doesn't allow you to contact a different server. I mean, actually, it allows you to contact, but not read the answer. But again, for Thursday. So let's see the code of the server. So you see that from today's lecture, we will always have two folders, client and server, okay? Because we are developing with the server from now on. So the server index, that's the code that you saw on the slide, flip, it's fine. And this app use core, this is simply a package to install, okay? Okay, we have to do that. Okay, good. So just an additional thing you can do, which is sometimes useful. And actually, it's an optional part in the lab. I invite you, I mean, next lab, tomorrow's lab is pretty simple. I invite you to try to do also this part, which I marked as optional in the lab. I mean, what you are going to do in case you contact the server and the server doesn't immediately give you a response. Of course, this computation is very simple. I mean, just take some letters and use a lookup table basically. But sometimes you ask the server, let's say, make a booking. You book a seat on a plane, on a train, and so on. It takes some time of processing time on the server. And then you will get an answer, yes, no, the number, the cost, I don't know, whatever, okay? So it is always a problem for the user when you click something, I mean, you do some action and nothing happens, okay? It looks like you didn't click well, you didn't do the right action and so on. You always have doubts, right? Using a site when you don't know the website actually sometimes. And or maybe you're not sure you pressed enough to get a click and so on. So it would be nice for the user if when you do something, okay, something happens immediately in the interface, and then when you get the response, you update the interface. This can be seen sometimes in websites. You load the page and you see something empty, and then it becomes populated later on. Okay, just in a few milliseconds, seconds, depending on the complexity of the response. Okay, we can do the same here. How do we achieve this behavior? Well, actually, it's a state. Okay, it is just a presentation state. It doesn't contain actual information. It just tells the component we are in a state in which we are waiting, and indeed we added a third state, waiting, the one you saw in the Visual Studio Code, which is just a Boolean, true or false. We are in a waiting state, yes. If we are waiting, we show a clock, whatever. I mean, you write waiting, please wait, whatever you want. If you are not waiting, you just show the content, okay? Or the content with the waiting icon. That depends on the application logic. You can do whatever you want, but just you need to show the user that you are waiting, that he or she is waiting, actually. And actually, just the state. So you just need to be careful when you set and reset the state. But actually, you have a function where you know when you get the response, right? So you get the response when you set the response here, set flipped. And so you can also set the waiting state to false here. And before calling an action and asking for an answer from the server, you can set the waiting to true. Okay? Or you can do it in the event handler. That's still fine. But you need to make sure that the text has changed, right? Otherwise, this effect will not run. So the best thing in this case is probably to do it here inside the callback of the useEffect, because you are sure that the callback is being executed. Okay? And of course, this makes sense if it takes time to load information from the server. Okay? Otherwise, this is barely visible. Like here, I think, were we able to see it? A, B, C, you see, you can barely see it. So sometimes you need to put an additional delay on the server just to see this behavior. Yeah, by the way, how do you put an additional delay on the server? Well, actually, it's very simple. You see, it's already there. Just use a set timeout on the server side, okay? And put what you want to do after the timeout as a first parameter in the form of a callback for the set timeout. Okay, like 1 second delay. Just remember, we didn't use the node mode, so we need to stop and start the server again. I hope I saved the file. Yes. So as you see the icon now, okay, because it takes time to get an answer. There is also this turtle here, okay, in the log, just to remind you. I mean, this was a slow answer, okay? Okay. I mean, this is just an additional state. So when you have states in React, you can play with the states. I mean, just to update the interface as you like. I would say if it's not explicitly required for the exam, there's no need to implement the waiting, okay? Even though it's nice, okay? But actually, I mean, it's not really strictly required. We care more about the functionalities, correct implementation of the required functionality than these things, okay? Okay. So let's just finish the discussion and then we will break. And then in the second part, we try to apply what we learned to our usual example. We have the question and answers, and we will try to load the questions. No, actually the question, yes, also the question, but actually the answers from the server. Okay, question is just fun, it's easy to get. Well, before we finish the discussion about the useEffect, there's still one thing I need to tell you about the useEffect. As I told you, useEffect is a quite complex API of React. Sometimes after you run the useEffect, you need to clean up things, okay? Like you set a timer, for instance, okay? For setting the state, like, I don't know, changing something in the interface, you want to periodically change. Then the component gets unmounted. And if you don't do the cleanup, it means you unset the timer, for instance, or you will keep calling a function. This is JavaScript. It has nothing to do with React. And if you do a set state on a state that doesn't exist, React, for instance, gives you an error. Okay, but it's not just about React. It's just cleaning up things in general. I mean, if you don't use something anymore, when the component gets unmounted, okay, you need to clean up anything that needs to be stopped or released and so on. Okay, how do you do it with the useEffect? Actually, the callback that you pass to the useEffect might also return something that will be used by React, okay? Actually, if the callback returns a function, the useEffect consider this as an effect cleanup. So, when the component unmounts, or basically every time you need to, you call the useEffect again for the same effect, before doing that, the function that has been returned before is called. Okay? So, in short, if you return a function, it will be considered by React a cleanup function, and it will be run when it's needed, when you need to clean up things for the component. Okay? Otherwise, you simply ignore this return value, as we did before. Right? I mean, there's no. Where is the useEffect? Flipped text. See, there's no return, right? So what's the return value in case there's no return? This is JavaScript, it's undefined. Okay? React will see the return value is undefined. Of course, will not call an undefined. But if you return a function, this function will be called when the cleanup is needed, which is actually what is written here. Okay? After the initial rendering, useEffect invokes the callback having the side effect. Okay, the cleanup function is not invoked, it's just stored. Okay? On later renderings, before invoking the next effect, next side effect callback, useEffect invokes the cleanup that you provided before. Okay? I must tell you, this situation is not so common because in our examples we don't really have anything to unset. I mean, the only thing that might happen is like you have a timer that you want to clean up, okay, after a certain time, typically that the component has been unmounted. Okay, that's probably the only situation in which you might have to use this function. Okay, but this is just for completeness. Okay. So useEffect, as a callback, the callback can do many things, and it can also return something to be run to clean what has been done. Okay. Remember that now, today, we have seen the useEffect. At the exam, I will see a lot of submission that will use a lot of useEffects. Remember that, I mean, the useEffect, of course, is very powerful because you can chain actions to the condition when props and states change. Okay? So basically, you can create state machines with this system. Okay? Outside of the React system where basically anything is rendered only when props and state changes. Okay? So it's very simple to think in terms of, okay, I need to do this. I create the state, I set the state, so the useEffect runs, and I do what I want, okay? But, I mean, try not to exaggerate in this regard because first, it makes your code very complicated, okay? Apart from less efficient, we're not caring that much about the efficiency, but I mean, it gets really complicated because, you know, state machines are typically complicated. So use it only when it's needed. Of course, when you need to interact with external asynchronous events, you probably have no other simple option. So like, as we saw before, we need to load data because something has changed and we need to talk with the server. That's a good way of using it, okay? In the beginning, when the component mounts, you have no other option, okay? But two very common cases where you don't need to use useEffects is transforming data just for rendering purposes, okay? Don't create additional states. Now you can create like a second state that depends on the previous state because you just put the previous state in the dependency list and you can run code and update the second state. Okay, but it's not a good way of proceeding because duplicating states is always difficult because at a certain point you will encounter some cases where you forgot to do some operations and the application breaks. Okay, so if it's just for rendering, just include the code as you did until now. Okay, until now you didn't have the useEffect, and so you had to, you know, run some code during the rendering phase. It means it's called in the body of the component. Like in the lab, you have the list of films. Okay, you have the filtered films. Filtered films are computed depending on the active filter that is a state, but you don't want to have a second state of the filtered films, containing the filtered films, okay? Because you can simply compute it. But now with the useEffect, you could do that, okay? But I mean, I don't want you to do that because it makes things much more complicated, okay? You can have the state of the full list of fields as a dependency in a useEffect, and there you can filter and set the state of the filtered fields, okay? That's something that in principle works, but in practice complicates things very, very much because now you have two states to care about, not just one, okay? So try to avoid this situation as much as possible. Okay, and then also handling user events. It's typically not that good that you, I mean, something happens, you set the state, and depending on the state, you have a useEffect that does something, okay? Not so good. Why? Because you have an additional state to care about, again. I mean, it's an event handler. You can do whatever you want. You can even run a fetch inside an event handler, okay? And we will see next time when we will implement actions like delete, add, update, and so on. You can run the fetch in the event handler, no problem, okay? You don't really need the useEffect. The useEffect is needed only when you need to run a code that depends on the change of some props or state variable. But if the action is clear, somebody has pressed a button and you need to contact the server. I mean, just contact the server. It's fine, okay? So instead, use effects basically when you want to synchronize with external systems, like in the beginning, you need to load the initial information. Okay, there's no other option. You don't want to have the user click, okay, start the application. I mean, there's no start application button. You want that the application starts by itself. So you need to attach your code to the mount of the component. Actually, the useEffect is the only way. Empty list of dependency and so on. Okay. This doesn't mean this is not I mean a very, very strict rule, but try to think if your code can be written without that useEffect. Okay. If it can, try to write it without it. Okay. It's true that sometimes there are convenient states, since you need to do many operations depending on many other conditions and so on. You just set a state and you trigger the execution of some code. It's probably a borderline situation where it's fine to use a useEffect, okay? But we will have a look at the useEffect at the exam for sure, okay? Because I want you to use them, I mean, not more than necessary, okay? Because just complicate the code, and actually it's a departure from the purity of the React components, okay? So in summary, 4 ways to call the useEffect. We said, okay, empty list of array runs only at mount time. No second parameters runs at every render. I mean, that's least useful of all of them, okay? List of dependencies, it runs only when at least one of the values has changed. And when the component unmounts, you have the opportunity to do some cleanup by returning a function that does the cleanup from the callback that you pass to the useEffect. Okay? So I think we can break here for, I would say, 10 minutes. And then we will resume just a few more things, but with fresh mind. And we will try to modify our example to get the communication with the server right. Okay? Okay, so no questions, right? So let's stop for 10 minutes. Okay? Thank you.